About application of dot product. So the first application and the most used application is to find the angle between two vectors, we use dot product. As we know, a dot b is nothing but ab cos theta. So we can find cos theta by using dot product and dividing by dot product by their magnitudes a and b. So let's see the first example. Again, the cos theta is nothing but if we know the dot product of the vectors and their magnitudes, the ratio of their dot product and the product of their magnitudes will give you cos of the angle between them. So we have to find the angle between vector A and vector B. Their magnitudes are given and their dot product is also given. That is 6. So if we go by the definition, the dot product should be A dot B should be, which is 2 into 4 into cos of theta, if theta is the angle between them. So we should get 6 as it is given as 6. So we can say cos theta is nothing but 6 by 8. Cos theta is nothing but 6 by 8, and we'll get 6 by 8 to be 3 by 4, and theta is cos inverse of 3 by 4. So this way we can find the value of theta. As this is not a very famous angle, we will not be able to move further. Now, if the vectors are given in vector form, then also we can find their the angle between them. Their dot product. First of all, we have to calculate their dot product. Dot product will be -2, and the second dot product will be 2. As the dot product is 0, oh my god, the dot product is 0. So we can say A is perpendicular to B. It's a very famous case. Whenever these vectors are perpendicular, their dot product will be 0. If dot product is 0, vectors will be perpendicular. Let's see a slight complex. These are the two vectors A and B. We have to find the angle between them. First of all, take their magnitude. You must know how to calculate their magnitude. Magnitude is nothing but sum of square of x, y, z components and their root. So 3 square, 4 square plus 5 square will give you nothing but 5 root 2. 9, 16, 25 will give you 50, and root of that will be 50 root 2. And similarly here, 2 square, 2 square and 1 square. Again, -2 square will be 4, whether it's plus or minus, it doesn't matter as far as magnitude is concerned. So it will be 4 plus 4 plus 1, that is 9 of root, and that is 3. So what is A dot B? A dot B is -6 plus 8 plus 5. So we are getting 7. Hence, cos theta, which is A dot B over AB, will get 7 by 5 root 2 into 3. And theta will be cos inverse of 7 by 15 root 2. That's all. So what if A cap dot B cap is given as, let's say, half? We can say cos theta is half. So angle between the vectors theta must be 60 degree. So what if A dot B cap is 1? We can say cos theta is 1 and theta is nothing but 0 degree. Okay. So whenever the dot product of two unit vectors is given, you can directly put it to be cos of the angle between them. In the next example, we have to find the value of this dot product when it is given that the angle between vector A and vector B is 60 degree. So we have to find this. When we take the dot product, we are getting A cap dot A cap with a minus sign. This with this. The second term we are getting is A cap dot B cap with 5 as coefficient. And the third term we are getting -3 B cap dot A cap. And the last term is 15 B cap dot B cap. As we already know, A cap dot A cap is nothing but 1, so minus 1, and 5 cos theta, as A cap dot B cap is nothing but cos theta. Similarly, it will be minus 3 cos theta, and it will be 15. So ultimately we are getting 14 plus 2 cos theta, where cos theta is nothing but half. So we are getting 14 plus 2 into half, which is 15 is the answer. In the next application of dot product is widely used in calculating many physical quantities like work. Work is force dot displacement, whereas displacement is nothing but final position minus initial position. Dot product is also used in calculation of work, power, instantaneous power, in fact, force dot velocity, calculation of flux, which is field dot area, calculation of current, which is current density dot area. So I have used few of these definitions in a very crude manner, but we can calculate these using dot product. In the next question, there's a force which displaces a point from this point to this. You have to find the work done. Work done is nothing but force dot displacement, which is R final minus R initial. This is R initial, this is R final. So what we get, 2I plus 3J minus 4K dot with final, which is 3I plus J plus 2K minus initial, which is I plus 2J plus 3K. So when we take the subtraction and do the dot product, we are getting 2I plus 3J minus 4K dot. This will get 2I, J minus 2J will be minus J, 2K minus 3K will be minus K. So what we get, that is 4, 3 into minus 1 minus 3, minus 4 into minus 1 plus 4, 7, 8 minus 3 will get 5. So if this is in Newton and this is in meters, we get the standard unit of work as joule.